Greetings, sports fans. Today is April the 7th, 2025, and this demo is going to be a casual description and demonstration of the new RADX Marathon PXIe and PCIe external RAID subsystems. And these subsystems are based on the HighPoint Technologies RS6541AW and the RS6542AW. That's a 4-bay and which is shown here, and an 8-bay system that HighPoint Technologies developed for PCIe, and we've now adapted those using our Catalyst technology to PXIe. So it's a very unique and powerful RAID subsystem that has some great attributes and features. For example, this particular system you see here has in it 4 micron 6500 ion 30 terabyte drive. So this is a 120 terabyte RAID array, and as you'll see shortly, that can support 7.1 gigabytes per second sequential read and sequential write performance into this PXIe 1092 chassis with a PXIe 8881 embedded controller. 7.1 gigabytes per second read and write for the entire capacity of the drives, 120 terabytes in this case. And these drives, which are based on U.3 or U.2 PCIe Gen 4, support Hot-Swap, and also they're order independent. So you can remove these drives. Let's say you're doing data capture in a car or a vehicle or whatever, or a lab, and you want to move this data rapidly to a PC system or a server. You can then just pop these drives out after you've disconnected them in software and transport them to the equivalent PCIe system, and you can reinsert them also while the system is running, Hot-Swap, in any order. They're order independent. So it's probably the easiest and most secure and highest performance way to move data from literally terabytes or petabytes of data from one system to another reliably, reproducibly, and quickly. So let's get into it here. So as I mentioned, we have our host adapter, we have the enclosure. This is a special PCIe interface. This is actually a Gen 4 by 16 host adapter, but we've adapted it to work in PXIe, so it's limited to 8 lanes. In this case, it'll run at Gen 3 by 8 because this is a 1092, but if you have a Gen 4 chassis, it would run at Gen 4 by 8. So in theory, it's capable of about 8 gigabytes per second. In practice, we see north of 7 gigabytes per second. FYI, that's a RADX Ada RTX 4000 GPU, in case you're interested. So we're going to go over here, and we're now going to run a benchmark on this array. And I've just started it up here. I'll move my handy camera over here. And I've started the benchmark. Now we're running Crystal Disk Mark, and Crystal Disk Mark is set up for a 64 gigabyte file, and we're using 8 megabyte blocks, 32 queue depth, or queue depth of 32, and 8 threads. And you can see on the performance meter here that we're writing to the drive at about 7.1, I'm sorry, we're reading from the drive at about 7.1 gigabytes per second. And you can see here it's consistent, reflected there. Now, on the Crystal Disk Mark, I've also set this up to write continuously for 60 seconds. So we're going to get a pretty good indication of performance. You can run it much longer, or you could use IOmeter, but in general, this thing will nail 7+ gigabytes per second for reads, and you're about to see that it will do the same thing for writes. And this is repeatable. You can download this from the Crystal Disk Mark website, etc., etc. But it's a good indicator of performance. And as I mentioned, so 7.1 gigabytes per second read, and you're about to see it finish up with 7.1 or so gigabytes per second write, sequential performance. Now the cool thing about this is that when you install and configure this drive, now you can see 7.1 gigabytes per second, it just shows up as a lettered drive. So there's nothing funky about how you use this thing. It's just a drive, and it just happens to be really fast and really big. So now you can see that we've finished our benchmark, 7.1 gigabytes per second read and write. And now we're going to do something really cool. We're going to remove these drives while the system's running. So I'm going to come back. So I'm going to actually what I'm going to do is I'm going to open the software to do that. So HighPoint has some really cool software that they've done that lets you configure, reconfigure, manage, etc. the RAID arrays. And here you can see I've got the 4 drives, 1, 2, 3, 4. They're all 30 terabytes. And the resulting RAID array is about 123 terabytes. I'm going to tell it I want to eject or unplug. So now I go here, and you can see I ask it to unplug. And if you listen, we'll start to hear some beeps. Now these are big drives, so it takes a while. There's one. Two. Three. 4. And now we can see that the RAID array is safe to remove, which is very cool. So I'm going to go over here now, and we're going to go look at the array, and we're going to remove the drives, and I'm going to put them back in a different order. So it's now safe to remove the drives. So this is drive M1, M2, M3, M4 for Micron. I'll zoom in so you can see that better. Now when I remove these drives, I'm going to put them back in a different order. Just pop it out. So here's drive number 4. I'm going to put it in the number 1 slot. I'm going to put, so this is drive 3. It's going to go in the number 2 slot. And then here's drive 2. It's going to go in the number 4 slot. And here's drive 1. It's going to go in the number 3 slot. So you can see I've mixed these all around. Now when you insert these drives, you have to really make sure they're seated properly. A, listen for the tone. But B, make sure that you feel a physical click. There's 1, 2. That one didn't go in very well. Let's try it again. 2, 3, 4. Let's see if they all got in there. It's thinking. We still have the RAID red light. I'm going to rescan. And now you can see that we got all of our drives in. It tells us that the RAID array is cool. And now we're going to rescan and make sure that everything is cool. And everything's normal. And we have all of our drives and the RAID array is fine. So I've now reinserted the drives with a different order. It's now 4, 1, let's see, 4, 3, 1, 2, as opposed to 1, 2, 3, 4. And we're going to rerun our benchmark. Drive E. So I'm on the wrong drive here. Let's go down to drive E, where the action is. And you can see that we're at 7.1 gigabytes per second. Should be wrapping up here shortly. 7.1 gigabytes per second for read. Now we're writing. You can see we're writing at about 7.2 gigabytes per second once it kind of settles down. Drum roll, please. And now we're at 7.1 gigabytes per second for write. So what we've shown today is that this new Marathon capability, which is based on the HighPoint 6541 or the 6542, which is an 8-base system, same basic concept, can support extremely high read and write, performance levels, 7.1 gigabytes per second, read and write in a Gen 3x8 PXIe chassis. And you can support up to today would be about 492 or so terabytes using 122 terabyte drives. Here we're showing about 120 terabytes using 30 terabyte drives. It's hot swappable, it's removable, and it's order independent. And if you have an application where you need to record data and then move it, or just need to record a massive amount of data, this is a really great system to do that. It's inexpensive, high performance, commercial off the shelf, and available today. Thanks.